With this lesson, we're going to do the sign of a function, okay? And we're going to be solving inequalities by using its graphs. Essentially, the title, I'm using the same title as the textbook, but the title is more about like, okay, let's see what the function looks like, and then, we can solve these inequalities. So hopefully it'll make sense, but let's get into it. Okay, so we've got these inequalities, all right? Now, the best thing we can do is think of its graph. Okay, y equals x plus 2, x minus 3, x minus 1, okay? Look at that graph, and then we'll be able to find out where it's less than 0, okay? So I know for a fact that this has roots at x equals -2, x equals 3, and x equals 1 from these things here, okay? It's in factor form, so it's really, really easy to see, okay? Now, I also know something else about this graph, and that it is going to be a positive cubic. And the reason for that is that the only way to get the coefficient of x cubed is I have to multiply these three things together, and there's no way I can multiply it without it being negative. So I know that this graph looks something like this, okay? Remember, positive cubic goes from lowest to highest. Now, if I did a rough sort of drawing of the x-axis, I know because it's roots that this is -2, that this is 1, and this is 3, okay? Now, that's all I need to know. So when is this graph less than 0? Well, it'll be less than 0 here and also here, okay? And because it's just, there's no equal sign, so it's just going to be between there. So I have to write that down. X is less than -2, and x is also a region. I'm doing this part here, okay? X is going to be less than 3, but greater than -1, okay? And I've answered my question. But for some of you, it might be a bit trickier than that. What I essentially want you to do is work with its graph. Now, if you're struggling with its graph, well, we have to go back to the lessons where we looked at all these things. So, and also, you get this opportunity to work with Desmos. Now, I've drawn it here. See, I've got the graph in red, and here it is. Now, that's not what I meant to do. I meant to put both things at the same time, so let's try that again. Okay, let's move that there. Okay, yeah. So we can see that we've got this graph. If I put this up, I can join it together so we're both live, okay? So what we can see is that what I just wrote there, you can clearly see the bits that are less than 0, and you'll be able to answer them by using its graph, okay? Now what I'm going to do, I'm going to take this away. I'm going to leave Desmos there because it's going to help us. And you can see that I've got a version of the answer next, but don't look at that. Actually, I'll move it across and then we can bring it back up, okay? So what I'm going to do is that this looks really complex to me, number 2. So what I'm going to do is move everything to the left-hand side. So I'm going to go x cubed minus x squared. So I've moved this guy over to that side, okay? And I haven't put the 1 in because I want to move the minus x. So now I'm moving this guy over there, all right? And then I'm just going to bring this guy back in, plus 1, less than 0. Because I've moved everything from this side to that side, I'm just left with 0. So let me get rid of all those markings I've made, all right? And I'm actually going to put a straight line there to put a boundary there. Now what I can do is I can partially factorize, okay? So I can partially factorize these two, and then I'll partially factorize these two. So let's go ahead and do it. So I'm going to get the first two, I've got a factor of x squared. Okay, so I'm taking a factor of x squared out of both these terms. So I'm left with x minus just 1. All right, that's really good. Now I have to partially factorize here. I can't really, but I'm going to take a factor of -1 out. Okay, minus 1, x minus 1 will give us back this thing over there is less than or equal to 0. Okay, so what I'm going to do now is I'm going to keep working on this. So I'm going to get x minus 1, x squared minus 1 is less than or equal to 0. Oh, this is interesting. This is difference of squares. So let's do that, okay? So we've got x minus 1. Now difference of squares of this guy. We've got x minus 1. X plus 1 is less than or equal to 0. Okay, I can do something. I've got x minus 1 times x minus 1. So that's just x minus 1 squared. And this is x plus 1. Okay. Ooh, now I know what this looks like. Okay. Now, once again, I know this is a cubic, and I know that it's a positive cubic. Okay. So it looks like this. All right. But I know something else. That this squared tells me that at x equals 1, because we get the root x equals 1 there, it's something. It's a turning point. It is a turning point, okay? And then we have a root. So let's write both the roots, okay? Roots at x equals, and it's minus 1 and 1, okay? All right, let's look at its graph. I'm going to put it on Desmos, and that's probably the next graph that you did see. Let's bring this in, okay? Now, what you can see is I'm going to put that graph on, is that the green graph is exactly what I've just said. So it's got its roots at -1 and +1. Hopefully you can see that in the video. Now, when is this less than or equal to 0? Oh, it's only in this bottom region here. I can't draw in Desmos, so sorry. So hopefully you can see that x is less than 0 when x is, well, it's just going to be less than or equal to -1, and also in one other place only, and when x equals 1, where the turning point happens, that can remain true as well. Okay, so hopefully that makes sense. Okay, so what I'm going to do is I'm really conscious about the videos taking a long time, so I'm going to cut it short. But I have this inequality. Now, this one's very similar to what we did last week or the week before. So we've got x plus 1 over x plus 4, all right? And we can make it less than or equal to 0 if you wanted to instead of the y, okay? And from that, we can work it out, okay? Now we have, the best way to do this is critical values. So we know that x cannot be equal to -4 because the denominator can't be 0. And we put everything on a number line, okay? The next thing, we solve as an equality. So we go x plus 1 over x plus 4 is equal to 0, okay? And then we solve and we get our two critical values. But what I want you to do is I want you to draw their graph on Desmos. Actually, I've got it here. All right, let's do that quickly. So I'm not going to solve this for you exactly. So it's the purple one there. So the question is, if I'm going to put these together. All right. Yeah. Say we had the same question as the previous ones. So I'm going to rub that off. All right. Say we've got, so I've just drawn that function in Desmos. All right, it's in purple. Okay. But say the question is x plus 1, x plus 4 is less than or equal to 0, from the graph we can clearly see where it is. Okay, when is it less than 0? And I go, well, if I find out what that point is there, and I've just clicked at that, well, it's going to be less than 0 when it's less than or equal to -2. There's no other place. Okay. Now, if you have troubles with that, let me know. But for the moment, that's our lesson. So peace